Hello friends, welcome to Data Science Lovers. In our last video, we learned about the identity function. In this video, we will learn about the zeros like, ones like and full like arrays. First of all, we will see ones like array and syntax and we'll do some examples. Then we have zeros like array with syntax and some examples. And at last, we have full like array with syntax and some examples for this. If you like our numpy playlist, kindly subscribe to our channel for more videos. Let's start. First of all, we have to import the numpy library in this Jupyter notebook, and the syntax is import numpy as np. From this numpy library, we will use the random module, and the syntax will be from numpy import random. The numpy library and the random module has been successfully imported in this Jupyter notebook. Now, first of all, we will talk about the ones like array. The ones like array returns an array of ones, means all the elements will be 1 with the same shape and type as of the given array. Means the shape and the type of this ones like array will be same as the given array that we will pass in the function. Let's see how. This is the simple syntax of ones like array function. From numpy library, we have to use ones underscore like function, and inside this function there are two parameters that we can use. First one is our array that we have already created, and this parameter array is mandatory, and second parameter is optional, which is dtype. Dtype means data type, in case we want to change the data type of our new created ones like array. Okay, now first of all we will create a simple 1D array, and the syntax will be from numpy library the array function, and inside this function we have to pass the elements that we want in our array. Suppose I create an array with 3 elements like this. I will save this in a variable a. When I print a, then this is our 1D array with 3 elements. Now I want to convert this array a in a ones like array. How can I do? As per our syntax, we have to use numpy library, then ones like function, and our first parameter is array, means that we have already created. This is our array a. I will use this a here. Okay, and we will save this in a variable name b. When I print b, then you can see all the values, all 3 elements of this array a are now converted into 1. This is the ones array. Now I think this definition is clear to you. It returns an array of ones, all values are ones here, with the same shape and type. Here our last array shape is 3 and type is integer. Here also in our new created array, the shape is 3 and type is integer. Now we will do one more example. Suppose from the random module I create a random array of shape 3 by 4. I am creating a 2D array 3 by 4. Okay, we will save this in a variable c, and when I print c, this is my 2D array with random values. Here are 3 rows and 4 columns. All values are in float format by default. Now we will convert this array c in a ones like array using ones like function, and the syntax is np dot ones like our array. We want to convert c. Okay, we can also give second parameter data type, which is optional, but I am not passing here, and we will save this in variable d. And when I print d, you can see all the elements of array c now converted to 1, and as all the elements were in float format, in our new array also the element 1 is also in float format, and the shape of our array c was 2D, so our shape of array d is also 2D. Now if we want to change the data type of our array d, then we can use our second parameter dtype. The syntax will be same np dot once like our array C. This time I will pass parameter d type equal to int. We will save this in variable d, and when I print d, you can see the shape is same, which is 2D, but the data type of the elements is now converted to integer format. Earlier it was in float format. So that's how we can change the data type also in ones like array. Next we have is zero like array. The zero like array returns an array of zeros as cleared by this name, the same shape and type as of the given array. This definition is similar to the our ones like array. And the syntax is, from numpy library we have to use zero like function. Inside this function there are two parameters, array and dtype. So let's see how we can work on zeros like array. We will take our array A for the reference. This is our array A, 1D array with 3 elements. We will convert this array A in zeros like array, and the syntax will be np dot zeros underscore like function. Here we have to pass our array, which is A. We will save this in B, and when I print B, you can see all the values, all the elements of array A are now converted into 0, and the shape is same as our array A, which is 1D. So that's how we can create a zeros array from an existing array. We will do one more example. Suppose I create a random array using the random module. Np dot random dot rand function I am using this time, and we have to pass the shape 5 by 2. If you learn about the random module, then you can watch this video. Here we will save this in C, and when I print C, you can see it is a 2D array of shape 5 by 2, and all the values are random in float format. Since we use the rand n function, the values are positive as well as negative in this array. Now we will convert this array C in a zeros array, and the syntax will be np dot zeros like our array name C. We will save this in a variable d, and when I print d, you can see all the elements are now converted into 0 with float format, and the array dimension is 2. It's a 2D array. Now we will change the data type of this array d using the dtype function, and the syntax is np dot zeros like our array C, and our second parameter dtype equal to int. We will save this in D only, and when I print D, then you can see all the elements are now integer format. So that's how we can create zeros like array with float format by default and in integer format by changing the data type. Next we have is full like array. The full like array returns a full array of constant element with the same shape and type as of the given array. Let's see, this is a syntax np dot full like. First parameter is array, mandatory. Second parameter is fill value, which is also mandatory. And third parameter is dtype, which is optional. Again, we will take array A for our reference purpose. This is our array A, and we will convert this array A in a full like array using this syntax. np dot full like. First parameter our array, I am using A array. Our second parameter mandatory is fill value. Suppose I want to fill this array with a value 7, integer value 7. We will save this in B, and when I print B, you can see all the values are now converted into a constant element, or you can say constant value of 7 that we passed here. So that's how we can create a full like array also using full like function. Let's take one more example. Suppose I have a random array from random module. I am using randn function, and if I create a 3D array of matrix 2, 3 rows and 4 columns, we will save this in C, and when I print C, this is our 3D array which is represented by these three square brackets in the starting and also at the end. We have two matrices and three rows and four columns in each matrix. Now we will convert a array C in a full array, and the syntax will be np dot full like our array name C and our second mandatory parameter, which is a full value. Suppose I pass 71 here, and we will save this in D, and when I print D, all the elements are now converted into 71, but by default all the elements are in float format. Here you can see 71.71 point. Okay, if you want to change the data type of this array as we did earlier, np dot full like here our array. Suppose this time I want to fill this with a negative value of -71. Also I want to change the data type to integer, so I will pass int here, and if we save this in any variable, suppose e, and when I print e, all the elements of our array C now converted into a negative value of -71, and the shape will remain same, which is 3D. So this is simple, friends, creating full like array, zeros like array, and ones like array. The syntax is almost same,